Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue my very popular series on great questions in web handling. In this short clip, I ask and try and answer the question of what elastomeric cover is best for your roller. I know your time is precious, so let's get started. As I've opined on many occasions, best is an economic term, not an engineering one. While engineering or experience might get you good or even good enough, the term best is reserved solely for maximum profit or minimum loss, whether for rubber cover, chemistry, or just about anything else. Given that caveat, we can attempt an engineering answer. The first step is to precisely define the application. There's a major difference between a lay-on roller cover running at 1/10 of 1 pound per inch of nip at room temperature and a calendar cover in the paper industry running 1 ton per inch at temperatures near the boiling point of water and when running at highway speeds. The next step is to carefully define what problems you are having with the current cover that brings this question up in the first place. Then we must select chemistry, which is more about trade-offs than it is about making a wish list of properties. After all of that, we finally select cover hardness, the subject that we will spend much of the time on here. We will call any of these materials covers rather than elastomeric covers simply because some covers are not made of elastomers. Also, the word rubber is quite old-fashioned, as almost no covers are made of natural rubber. The most important point I will now make is this. That is, cover materials, and especially compounding chemicals and process recipes, are hidden by trademarks so that the customer and even the rubber cover suppliers may not know what they are buying or selling. The last step in ordering a cover is to specify hardness. The common test standards and instruments are listed here. One of the more nuanced topics I discuss in my award-winning and trademark Web 101 class that has been taken by 5,000 people is this. That is, hardness affects nip footprint and peak stress. If you want to have a higher stress for some specific process application, you can get there by either higher nip load and or a harder cover. We discussed many other trade-offs in our class, including the TTPs, time, temperature, pressure of product development, and the TNTs, tension, nip, and torque of winding. Oh, but wait! There's more to hardness than merely stress. Softer covers conform to non-uniformities of the roller and web alike. This might make products and processes more uniform. So, why not use very soft covers for uniformity that are highly loaded to get the job done? So the best way to think of best hardness, for at least some applications, is via trade-off. Just like chemistry is a trade-off between conflicting wishes, so too is cover hardness. Harder covers have longer lives, but have worse conformity to roller and web imperfections. Softer covers are more tolerant, but wear out quicker. Thus, the trade-off can best be answered by the minima of the sum of the cover costs and the non-uniformity costs. So, where does that leave us? more or less back where we started. That is, that wide application experience is probably going to get you farther than rules of thumb or even science, and that economic analysis is not common and thus might not fit in most people's bandwidth. So, how do you find that wide application experience? Probably by finding and getting to know the oldest and most widely traveled of rubber cover service engineers, if there be such a thing anymore. Thank you so very much for allowing me to share my thoughts on great questions in web handling. Stay tuned for next week's show, where we will talk about why your machine speeds and your product lengths might not be quite correct. If you have a topic you would like to know about, let me know in the comment section below. If you found something interesting or useful here, please like and share and subscribe. See you next time.